Okay, let's give you guys some practice now. So determine if this series will converge or if it will diverge. Because it contains n factorial, you should use the ratio test because the ratio test is very good with dealing with factorials. So use the ratio test. So press pause and have a go. Okay, so to use the ratio test, we're always after this value here. When using the ratio test, we're always after this value here. So it will be an plus 1, which will be this, divided by is the same as multiplying the reciprocal of an, which is this thing here. So yeah, so this whole thing here will then become this. So now it's just a matter of tidying this up. So when you get to this stage here, have a quick glance in the realm of one to infinity, uh, everything here. This will be positive. This will be positive. This will always be positive. This will always be positive. So you don't really need the absolute sign. So you can just get rid of the absolute sign. So from here, when you get to this stage here, have a quick glance in the realm from 1 to infinity. It's always going to be positive. So we don't really need the absolute sign. So that will then become this. That will then become this without the absolute sign. So now it's just a matter of tidying this up. So if you look at this and this, n plus 1 factorial is the same as n plus 1 times n factorial. Because if you let n be 4, then n plus 1 would be 5 factorial. Well, that's the same as 5 times 4 factorial. Well, n plus 1 factorial is the same as this. So rewrite this as this. So now this thing will cancel out with this thing here. And also looking at this, because well, if the trick here is to multiply this bit out. If you square this, it will then become this. And then once you're here, then this then becomes this, because x to the power of a plus b, that's the same as x to the power of a times x to the power of b. So you can jump from here to here. So hang on, let's start again. We were here. So reimagine this as being this, and then we can see that this is going to cancel out with this, and then multiply this out. That will then give us this. But then rewrite this as this. So that now what you've got is one block multiplying another block, and then looking at this block. This block here gets cancelled out with this. So these two will cancel out, leaving you with this, with this. Basically, once you're here, e to the power of 2n times e to the power of 1, then I'm just rewriting it as this. Okay, so that's e to the power of 2n plus 1. So basically all that you're left with will be this thing here, but rewrite this as e to the power of 2n plus 1. So now it's just a matter of us determining. We are trying to determine the limit of this as n heads towards infinity. So as n heads towards infinity, the numerator will be infinity, the denominator will be infinity. This is an indeterminate form, so we can use L'Hopital's rule. So L'Hopital's rule is to differentiate this, differentiate the top, differentiate the bottom, and then evaluate it again. So as n heads towards infinity, you can see that the whole thing here is going to be 0 because the denominator will just get bigger and bigger and bigger. So the limit of this whole thing as n heads towards infinity will be 0. So going back to the very start, we were trying to determine this. We were trying to determine if it will converge or if it will diverge. We would use a ratio test, but with the ratio test, we need to know the value of this. Well, the value of this happens to be 0. We just worked it out to be 0. So now this value here is less than 1. So while it's not, the value is not greater than 1. So this is out. It's not, the value here is not equal to 1. So this is out of the question. So now this is our our situation here. So our value here is actually less than 1. So we can say that the original series will converge. So that will mean the original series here will converge because this value here is less than 1. Okay. So the conclusion is that this series will converge.